Welcome back. In this section, we are going to cover the scatter plot. And this question, I've taken it from the November 2016 question 1. The question reads as follows. A survey was conducted at a local supermarket relating the distance that shoppers lived from the store to the average number of times they shopped at the store in a week. The results are shown in the table below. So we are given here data that is collected. We are given the various distances here that the store is, and then the average number of times shopped from that store per week. So that is the information we are given. And here we have got a scatter plot. I will explain in a while what is a scatter plot. So then the question says here, use the scatter plot to comment on the strength of the relationship between the distance a shopper lived from the store and the average number of times she or he shopped at the store in a week. So we can see that here. Let me first of all explain the scatter plot briefly. What is scatter plot? So a scatter plot is a plot of bivariate data which shows a relationship between two sets of data. So there are two sets of data here: the distance from the store and also the average number of times shopped. So now we might find that there is a relationship, which is what we are asked to comment on here. So we might find that there is a relationship between the distance from the store and the average number of times per week. Well, we might conclude and say the further the store is from us, then it means it might be less likely that we will shop from that shop. So that's what we have, or we will shop from that store. Now, so there might be a relationship. So that information is represented by what is called a scatter plot. Scatter because we've got the points that we plot here, okay, that are scattered. So how we got that point is that we have got point 1 when the distance is 1, the number of times is 12. So 1 kilometer away, I'm more likely to visit. Okay, 2 kilometers, there were 10 number of times shopped. If the shop is 3 kilometers away, there are 7 number of times. 4 kilometers, so we see some dots over here, scatter plots. So those dots are representing the relationship between the number of times that is shopped and the distance from the shop. So we can represent it as a graph like that. Now, coming to the question, which is asking us to comment on the strength of the relationship between the distance. Now, the strength, we can see that there is a strong relationship here between the distance covered, distance from the store, and the average number of times shopped per week. There is a strong. Now we can also say that there is a strong negative relationship, meaning that the further away the shop is, the less the number of times shopped in that. So you can see there is more like a downward trend. There is a downward trend. So to answer that question, remember question 2, there is already a page that is prepared for you to write here. So you can write the answers here in the answer book and say there is a strong negative relationship. There is a strong negative relationship between the distance from the store and distance and the number of times times shopped. Most of the time you'll find that this question is asked after we have calculated what is called the correlation coefficient. Now I explain later what a correlation coefficient is. Basically a value that it tells us about the strength of the relationship between the variables. That is how well they are close to what is called the regression line. We'll explain further on that. So here we can see that these points here, they might, if we were to draw a regression line, which is also called the line of best fit, you find that these lines might be very close to that line. So there's a strong association. But now how strong? Because it is a downward trend, so we'll say that there is a negative association. There's a negative relationship, meaning that as one quantity increases, the other one is reducing. Now, question 1.1 is done. Let us look at 1.2. Question 1.2. Question 1.2 is to calculate the correlation coefficient of the data. Calculate the correlation coefficient of the data. The correlation coefficient is represented by R. And to do that, we have to enter our data values in a calculator and then just extract the value from there. So what we do is we have here the calculator. So we have to put it in mode, and in statistical mode here 3, and then let me just move it a little bit here. Right, and then from there we have to enter, because we are entering bivariate data, there are two sets of data. We use option 2, which is the regression option A plus BX. So from there I will choose 2, and then I'll have 2 columns where I'll enter the values. So it's 1, 2, 3, 4, 5, 7, 8, 10. That we can say is the X values. These are the X values, and these are the Y values. So let's enter them like that. So I'll have here 1 like that, 2 equals 3 equals, and so on. And then we move on to the other set of data, line them up. So I have 12, 10 equals 7 equals 7 equals another 7, a 6, a 2, 3, and 2. So we have entered that, and now we are going to press AC, shift 1 here, and 5, we go to regression 5, and we'll find the R there, which is a 3, option 3, press equals, we'll get the value. So R is equal to negative 0.946. Okay, so you just have to write that value down over here. So let's write it down. R is equal to negative 0.946. Now, one thing that you will see the value r there is that it is negative, and the number 0.9 is close to 1. So the negative, it means there is a negative relationship, and the 0.94 is close to 1. Let me just explain that in a while. The correlation coefficient is a value that ranges between negative 1 and 1. So when it is on the negative side, we described it as negative association. When it is on the positive side, there is a positive association. So this is positive and that is negative. Now, any value that is close to negative 1 is close to being perfect. So we can say that our R, there is a strong negative association. Actually, we can just write our values like this. I can have, let's say, from the 1, I'm starting from the positive. Let's take a value like 0.9, and then 0.5, and then a 0.2, and then a 0. Then I have also a 0.2 on the negative end, then a negative 0.5, and then a negative 0.9 and something, and negative 1. So I've moved from 1 to negative 1. So anything NR that is equal to, roughly equal to that, we describe the relationship as a perfect positive association. That is a perfect positive association. If it is something along 0.9, that is a strong positive association. If it is 0.5, we can say it is moderate, because moderate is a number between 0 and 1, halfway between 0 and 1, so it's moderate. And then when it is 0.2, somewhere there, we can describe it as a weak positive association. When it is 0, the R is there is no correlation. There's no association. There's no association. Then when we come to the negative end, we are just replacing the positive term with a negative. So this will be weak negative association, moderate negative association, strong negative association, and a perfect negative association, which means all the data points are lying close to the regression line. So if I were to have a line here, the points are exactly lying on the regression line. So that's a positive. But if it is 0.9, which means they are quite close to the line, but a little bit further out. So the smaller the number, the further away from the regression line the data points are. So that's what the R relates to. So R, it tells us about the strength of the relationship between the variables. Now, question 3 is to calculate the equation of the least squares regression line of the data. The least squares the regression line of the data, and the answer we are supposed to write it here. Now, the least squares the regression line is written in the form y hat is equal to a plus bx. Okay, so it's more like the equation of a straight line. Y is equal to mx plus c. So a is the constant, which is your intercept, the y-intercept, and the b is the gradient of the line. This is the gradient of the line. So all we have to do is to extract the A value and the B value from our entries. Now we have the values in our calculator. So remember, we used R is equal to that, so we can still use that data set. Shift 1, go to shift 1, and then go to regression again 5, and then we'll see our A here and the B. So I'll choose A, which is 1, and I'm getting 11.713. So I'll just write here A is equal to 11.713. So that is the value of A. Let's come to B. To find the value of B is again shift 1 there, and regression 5, B2. So equals, I'll get -1,118. Negative B is equal to -1,118, which is expected because our line is a negative association. Downward trend is a negative gradient. So which means therefore our y will be equal to A, which is 11,713, minus B, which is minus 1,118 by x. X being the number of kilometers that the shop is away, and Y being the number of visits. Number of visits? Yes, number of times shopped per week. So this is the y-axis over here, and this is the x-axis. So our equation is given by this statement here. Then we come to 1.4. 1.4, use your answer at question 1,3, which means that equation that we have just obtained, to estimate the average number of times that a shopper living 6 kilometers from the supermarket will visit the store in a week. Now, here we have this term here, the least squares regression line. Maybe something that I should have explained from the beginning. Now, what is a least squares regression line? Now, a least squares regression line, it is a line that is used to show the general trend which a set of data follows. So we use this line to show us a general trend. A trend is just a pattern. So if I were to look at the trend, the pattern of these points here, so I can draw a line. Some call it the line of best fit, or it is also called the least squares regression line, or sometimes it is just referred to as the regression line. So that line is a straight line. Well, it depends on the data. In this case, it will be a straight line, and the line just generally shows the trend, the pattern, okay, that we find in our data. So the trend here is that as the distance increases, the number of times shopped per week decreases. So we use a straight line to represent that. Now, the purpose of that line, the least squares regression line, it is used in what is called interpolation or extrapolation. Interpolation is merely predicting the values of one variable when one of the corresponding value is given. So what I mean by that is, suppose, let's say, I have a distance here of 5,5 kilometers, because that distance is not recorded here. So let's say I have a distance of 5,5 kilometers, 5,5 kilometers. So what would be the expected number of times per week? So we predict that. So that is what is called interpolation. Interpolation, it means you are predicting the values based on the range, the domain that you have from 1 up to 10. Extrapolation means you are predicting values based on the values that are above those that you have recorded. Like here, our recording ends at 10. So extrapolation, it means you are now trying to predict any values beyond 10. For example, if it is 11 kilometers, 15 kilometers, and so on. But if it is interpolation, you are working between the 1 and the 10. So basically what we are saying here is the regression line is a line that is used to predict values of one variable when the corresponding values of the other variable are given, or when it is given. So in this case, we are asked to estimate. So it's a prediction. So we are estimating the average number of times. So remember, the average number of times is the y values. These are the y values that a shopper lived 6 kilometers from the supermarket. So you find that when we come to our data set, this person did not record 6 kilometers, just recorded 5 and 7. So if the distance was 6 here, okay, so how many number of times would we expect? So that is the prediction. That's how we use the regression line. So what we have to do is we have given our 1,3, so we are given y is equal to 11,713 minus 1,118x. So x is 6. So we are now finding the estimated value for y is 11,713 minus 1,118. So if my expected distance is 6, how much would that be? So we just punch that in a calculator and then we get the answer. Let's get it there. So what do I have? I have 11.713 minus 1.118 into 6. Let's see, 118. I entered the 3 1 there, so delete one of them. 118 by 6. So this is the answer. That is 5.005. So I'll get 5,005. So these are the number of times. So we can say the expected number of the estimated number of times is 5. So we expect the number of times per week to be 5. So that's what we have. Now then we have got the last question. Sketch the least squares regression line on the scatter plot provided in the answer book. This is one of the reasons why I chose this question. Sometimes they can ask you to sketch the least squares regression line on the scatter plot. So we are given the scatter plot here. This is the scatter plot. Of course, you will be given a scatter plot like this in the answer book. So we are going to sketch there. Now, for us to sketch the scatter plot, it's a straight line. So we have to make use of this equation 1. So we have to make use of that equation. And also one more thing, which is called the mean point, x bar, y bar. Now this is compulsory. For you to draw a scatter plot, you need to determine what is called the mean point. The mean point of the data values. Now, the mean point simply refers to the mean of the x values and the mean of the y values in the data entries that you've done. So let's try to extract here our mean. We have our data values already, so I'll just have to shift to 1 and I'll go to 4 variables, and x bar is here 2, which is 2 equals, so I will see it's a 5. So my mean is, this is the mean of the x values. So I will just register it here. That is a 5. X bar is a 5. And the y bar, let's extract the y bar. The y bar is shift 1 again, 4, and then y bar is at number 5, and then I'll get that. So I'm getting 6.125. So that is 6.125. So this is my mean point. So what you will do is you have to go and plot that point. 5 versus 6.125. Now you'll find that this 5 is here, 6, this is 7. Yeah, it's slightly above, it's slightly here on that point. So this is a compulsory point, if I may put it that way. In other words, every regression line should pass through that 5 and 6.125. You have to have that point. And then after that, you can now find another point. Remember, to draw a straight line, you just need 2 points. This point and any other point that you get. Now, to get the other point, I can just use any value that I want. I can substitute a 1, a 2, a 3. Is preferably these values that are far away. I can maybe choose a 9 so that I can join 9, that point, and that point. Then I'll get a straight line, or any line, any regression line. Or I can choose a 1. So what I mean by that, let me just choose a 1 so that it is easy to calculate. So I'll come back to the line now, to the equation. Remember, the equation is y hat is equal to 11.713 minus 1,118 times. So I'm saying if my x value is a 1, what will be the estimated average value? So I'm just literally getting 11,713 minus that. So let me just subtract that one in the calculator. So we have 11.713 subtract 1.118 equals, so I get 10.595 or 10.6. So this will give me 10.6. So what it means now is I've used my regression line to find a point that is 1 and 10.6, the average point. And I've also gotten my mean point, which is 5. So let me just plot that 1 and 10.6. So when it is 1 here, I'll go to 10.6, somewhere slightly above half there. Okay, so then what we do from there is to join those 2 points. So let's see if I can just connect a line here. So from here, or maybe I can just put it like that so that it passes through this point. Okay, right. I also have to, to make it a bit longer here. Let me just take another point from here, because it has to go straight up there. Right. It has to be something like that, one continuous line, and that line is now our regression line. So the main thing here is that the line must pass through the midpoint, the mean point, and also one other point that you use. In this case, we used this point 1 and 10.6. This line, you get it from the least squares regression line. And this one is the X bar, Y bar. This is compulsory, so we call this one the mean point, which is the average of these values, X bar, and the average of those values, the mean of the X data values and the mean of the Y data values. So then you have to draw a line passing through that. So I was supposed to extend it further to the end here. Okay, make sure that it crosses the x-axis up to the x-axis, and they are also over here. Now, that covers this section on the regression line. So many things that we have covered here, and if you have enjoyed, have you learned something from this tutorial, please let me know on the comment section. Give your feedback, and also just click on the notification bell so that if we get any information posted, you will not miss out. Otherwise, have a wonderful time, and we'll see you next time.